Good morning. Welcome to another session on environmental impact assessment. We shall continue with Unit 5 case studies. Course outcome: describe the EIA for various infrastructural projects. Learning outcomes: explain the EIA for water supply scheme. Specific outcomes: explain the impact of water supply scheme on the environment. Scope: the term rural water supply covers all the measures taken to satisfy the demand of water in the predominantly rural regions. So actually here I have taken the example of rural water supply scheme, right? The same thing can be modified or extended for a urban water supply scheme. So the rural regions of this kind may be classified as nomadic ways of life or peasant ways of life or peri-urban ways of life, right? Uh, Especially this rural water scheme actually is for people who are living in villages and remote areas. Most probably they're doing some farming sort of thing, right? So peri-urban ways of life does not include plantations and large-scale agricultural undertakings. Rural water supply scheme embraces the supply of drinking water and household water to the rural population plus supply of water required for the purpose such as garden watering. However, though this constitutes an environmental problem in its own right, rural water supply scheme also includes the watering of livestock plus the supply of water for livestock watering, because in rural areas it's virtually impossible in practice to draw any clear distinction between drinking water for humans and drinking water for livestock. So livestock is the animals that are used for farming, right? And you have something called cattle grazing, right? You have cows, bullock carts, right? So these all come under livestock. Supply water for general agriculture purposes does not come within the scope of rural water supply. In particular, rural water supply does not cover systems for the irrigation of fields or rural hydraulic engineering works. In contrast to the urban water supply system, there is no pipe distribution in majority of the rural water supply systems. Exception to this rule are the supply lines and the generally quite short runs of pipes, that is in deprived areas from the rudimentary networks, supplying public standpipe systems in spread out villages. So generally in villages you don't have the pipe system. So there is a major distinction between the rural scheme and the urban water supply scheme. So when you write or when you look at the impacts for the urban water supply scheme, you'll have a lot of piping system. So you have to take the impact caused by the corrosion of the pipes and impact of all the metals or materials with which the pipes are made on the water supply, right? So that will not come here. Water demand must inevitably adjust itself to the supply that is present and usable. Where it is simply a matter of supplying the rural population, demand is generally between 15 to 30 liters per person per day, LPD, 15 to 30 LPD, that is liters per day, and sometimes even less, and it seldom rises to levels more than 60 LPD. Right, to cover the demand of water for livestock, an additional 15 LPD will be needed for each small animal unit and around 75 liters per day for each large animal unit. So generally when we look at urban systems, the water demand is 135 LPD, right? A person uses 135 liters per day in urban areas. So in rural areas not much water is there, and you cannot have 135 LPD. So it is about 30 LPD, or at the best 60 LPD plus for plus about 15-20 for the livestock. So hardly it will cross 100 LPD. Depending on the nature of abstraction, rural water supply can be divided into following types: water from the groundwater, water supply from the surface water based on the use of surface water, and use of water furnished by precipitation. So to meet the demand, use is often made of all three sources simultaneously, that is groundwater, surface water, and water from the precipitation. Unlike public urban water supply scheme, where use is made of large centralized abstraction system and reservoirs and a connected distribution system, what is typically of rural water supply scheme is so-called decentralized water supply system, where the beneficiaries often assist in constructing the system under self-help projects and later on become responsible for operating it. So when you look at an urban water system, you will have a reservoir or large area where water is stored, right? Especially when you have dams. Behind the dams, there will be an area where water is stored in large quantity, which is called the reservoir, and from the reservoir, water is supplied to the uh, cities and towns in pipe network systems. Here we don't have such systems, so it is a decentralized water supply system or scheme where some small water storing areas or water storing structures are constructed, and people take responsibility in operating them for the whole village. Relatively small groups of consumers ranging from a single family to village communities or nomadic herding communities obtain their water supplies from small, often scattered and sometimes widely separated individual abstraction systems with no distribution system. Water carrying traditionally being the domain of women and girls in rural areas. What is typical of decentralized groundwater abstractions, dug or drill wells or spring tappings? The lifting units in the systems are generally small to match the number of consumers, the water source, and the generally limited construction resources. Their capacity is of order of 1 meter cube per hour in case of village wells and up to 5 meter cube per hour in case of wells on pasture lands. Lifting is generally carried out by traditional means operated either by hand or by draught animals, though use may also be made of mechanical lifting aids such as hand operated or motor driven pumps, right? Generally diesel pumps, bucket chains, etc. Artesian wells in which the water is confined and rises to the surface without the need of lifting are rare, meaning you have some areas where the water will just come out like a spring. Okay, so such systems are very rare. You don't find that very often, right? Simply you drill a well in that particular place and water will just jet out, meaning you don't need any pump to extract water. In some cases, water is lifted into community tanks, which are closed tanks of 2 to 6 meter cube capacity fitted with a tap. Characteristic feature of abstraction from surface waters is small impoundment works, normally earthen dams. The hallmark of precipitation water use is cisterns, ranging from buckets through water barrels up to closed tanks made of concrete, sheet, steel, or plastic, and the associated intercepting and collecting surfaces such as roofs and slopes. The predominant method of conveying water between point of abstraction and point of consumption is still transport in portable containers or by using donkeys, generally a job done by women and girls. Right, so nowadays you don't find any donkeys carrying water. It was in the olden days. So generally you have women carrying water on their heads, or nowadays you have some people use some cycles to carry water in pots, or even motorcycles. You might have seen two cans on either side of the cycle, or what motorcycle. That's how people carry water in rural areas, right? So nowadays I don't see any donkeys. Supply pipes are rare and generally very short. Transport considerations mean that drinking troughs for livestock are generally sited immediately adjacent to the abstraction or collecting point. An important part in rural water supply projects is played by local measures to regulate the supply, particularly when the amount of water available is restricted. Such measures include, for example, restrictions on the daily periods of withdrawal and pumping, and on the volumes lifted, and measures to control the consumption, such as suitable pricing. Right. So let us start looking at the environmental impacts. So impacts from rural water supply projects are possible, and they are primarily divided into two categories, that is qualitative and quantitative. Qualitative means whether it's good or bad, or something you are commenting on the quality aspect. Qualitatively we are looking at the impacts. Quantity meaning what is the degree of impact in terms of quantitative, it's going to affect so many people, or you will get these type of diseases, something like that. So we can quantify the impact. So these things occur as a result of abstraction of water, that is overuse of resources, lifting, storage and distribution of water, actual allocation made, uh, that is requirements and mode of use. As well as above, there are also possible secondary and tertiary impacts on the environment in the event of increased demand due to positive feedback, overtaxing of the resources due to a good water supply for a short period, accompanied by overgrazing and gnawing of vegetation, and changes in the custom mode of use. Some additional impacts, secondary and tertiary impacts. Environmental protection measures will therefore be qualitatively and quantitatively oriented, and hence will be chiefly concerned with strategies for preventing overuse of water and threats to its hygiene. This means not simply measures that are technically feasible, but above all complementary efforts to produce organized self-help in the form of instructional and hygiene campaigns, with women playing a crucial role in these, not just in the planning but above all in the implementation procedure, right? So what the protection measures are generally to prevent the overuse of water and also to keep the water clean, right? So that people are healthy and fit, right? So that has to be done through some campaigns, especially in which women need to take part because they play a major role in, especially in rural areas, in carrying the water or storing the water, transporting the water, and so on, right? Quantitative overuse of water resources and threats to their quality. Water resources may be adversely affected not just quantitatively but also qualitatively. So it is not the volume of water that is getting affected; it also gets affected in terms of quality, in terms of their quality and hence their fitness of use, which may occur due to pollutants, bacteria, etc. The impacts on them exerted by rural water supply operations may affect them in the same way. In cases where precipitation is collected, overuse is ruled out by the natural limit on the water collected, whereas in case where water supplies are abstracted from surface waters, threats may arise to the water sources, particularly with respect to the quality. Where the most serious adverse impacts are possible, however, is where supplies are abstracted from groundwater. In this case, there may be permanent, irreversible, deleterious effect on the resource both in quality and also in terms of quantity. Fossil groundwater is a non-renewable resource, and as such, it should, if at all possible, not exploited in any way because it is very difficult to replenish the groundwater. It has to take place on its own, or you may have some artificial recharging system, but it is very difficult to recharge such a huge reservoir in a very, with little amount of water. You need a lot of water to recharge it. For groundwater abstraction, the open well is far more of a risk to water hygiene than a pumping system covered at the top. In many cases, it is likely in rural areas with well-developed structures that, given the relatively small volumes subtracted for rural water supply, the total available resources will have sufficient regenerative capacity to rule out any threat of sustained overuse. However, if there are other adverse factors operating, then undesirable overtaxing of the resources may very well occur in that situations. Right, we'll continue from this in the next half. Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.